Okay, so you have to factorize this. This is hard. Okay, so in this sense, doing it in your head makes little sense. Don't forget, you can do this on a calculator if you're so lucky to be allowed one, but it's difficult. You've recognized, first of all, you've got a quadratic, okay? So there's definitely a quadratic. The next thing you recognize is it's our general form that we're used to seeing. So we have ax squared plus bx plus c, meaning that we've got a special method to deal with that. When it comes to this, the difference I can see is that a is more than 1. So the grouping method, it starts 1 by multiplying the a term by the c term. Okay, so we'll do that on the left-hand side. So the a term here is 4, and the c term here is -3. So we write that down. 4 times -3 is -12. And now what we're going to do is find the factors of the 12 that we have there. It really doesn't matter, again, just like it did before, it doesn't matter whether it's positive or -12. So we're just going to go ahead and just write 12. So number 2 is we want to find the factors of a times c, we'll call it. And that's going to be 1 and 12, 2 and 6, 3 and 4. Now, 3 is we're going to split the b term according, let's write this fully, according to part 2. Okay, so we're going to split it according to part 2. What does that mean? Well, we're going to rewrite the quadratic equation question that we have, and instead of writing the middle term minus 4x, we're going to use one of these pairs down here to split it apart. Okay, so what would the best pair be? We want to get to -4, and this is not going to help us. This is not going to help us. We're going to go with 2 and 6. Okay, so remember that we had 2 and 6. I'm going to get myself some more space. And we're going to write very carefully here all the other elements in place, but instead we're going to split the middle term into 2 terms. Now these 2 terms, we said we're going to be 2 and 6. But what does that mean? How do we use 2 and 6 to get to -4? I'm going to write this here just to remind me what I've got. And then we're going to take away the 6x, and that will give us the equivalent expression of -4x. As you can see, if we wrote this, it would be the same as -4x, so it's equivalent expression. Now, if we want to add this to the equation, a little tip ahead of time, and you'll see why this is important later, is that we put the number next to the, we put the particular term next to the term that would factorize best. Best way to see this is to show you the 2 versions that you could have. So let's say we've got the 2x, and it was positive 2x, and we have the -6x to the right. The alternative is the -6x there, and the plus 2x second. Now, in a moment, we're going to factorize both sides. So this is the first time we're going to factorize, and we're actually going to do it again. But I'm going to call it factorize the left and the right, because we're going to split this into 2 sections. So these 2 terms and these 2 terms are going to be factorized separately. We need to take a note of how we would do that, because the top, and I'll just underline it, clearly has nice numbers that have similar factors, and so does this, 3 and 6. Look at the bottom. Okay, fairly good. 4 and 6, we could still take out a 2 and an x. But if we look at the right hand side, not very good. So in this case, we don't have any common factors, so it wouldn't be a very good way to write that. So we're thinking ahead and we're going to write it this way round. Now, you can tell in a second whether this was the correct way round, because the brackets we're about to get should be the same on both sides. So let's go ahead and factorize the left-hand side. We're going to see that 2 goes in both and x as well. And then open a bracket. We divide by what we took out. So we're going to end up with a 2x there. And we divide by what we took out is 1, because it's the same expression. Now here we're going to add to it what we have. So -6 and -3, most certainly we could take out a -3. X does not go into both terms. So if we did take out a -3, -6, I'll write this down just to see it once, divided by -3. You can see the negatives cancel, and 6 divided by 3 is 2. And so what we end up with there is 2x, because there's no x to cancel out. Looking good so far, because 2x was in the other bracket. Now -3 divided by -3 is +1, because remember 2 negatives divided will give a positive. This is perfect. Look, the brackets that we have on both sides are equal. This is a sign that it worked. This is a sign that we did the correct factors at the beginning. It's a sign that we put them in the correct order. I can see that this is the term that is going to be in both. So instead of taking out a single term and factorizing, I'm going to be taking out a whole bracket. Done that before? What's really good about this is when we go to divide by what we've taken out. So if I say 2x, open bracket 2x plus 1, and let me be specific, we're talking about the left-hand side here, this as a whole. If I divide that by 2x plus 1, it's the 2x plus 1s that just cancel to give this term. So it's actually a lot easier than factorizing out, you see. So this one also has the common term of 2x plus 1. So if we divide by 2x plus 1, we're left with -3. And I suppose we just finish by saying factorize overall. And I think that might not be enough. I think we'll just say there will be a common bracket, because it's not too obvious at that stage how you factorize. So it's the bracket that's going to be in common. Okay, so these are the 2 questions that we're going to use to practice. We'll start with A. Good place to start as any. Now, we multiply the A by the C to give us 22. Now we've got factors of 22, and not very many. They're not brilliant. We think about which one of those would best get to 23. Okay, and we are going to pick the first one, because that the difference, or if we add them together, it gives us 23. So we're going to be going with 1 and 22. So that requires us to rewrite this question with 1 and 22. Now, thinking about it, I'm going to put the 22x with the 2, because it's an even factor there. And since the 11 is a prime number anyway, I'm going to be putting the 1x with the 11. So now I've got the 2 sides, and I'm going to factorize each side. The left-hand side gives me 2 and an x to take out, and that'll leave me with an x and an 11. This is looking good, I think. The right-hand side, that's not going to leave me with anything, but I have to put 1. There's definitely something that's in both, just to almost like a placeholder to see what's about to happen. So I could take a 1 out, but I'm just being aware that there's 1 of those x plus 11s. I can see now that the bracket is the same, so it's a good thing. And I'm going to factorize out the bracket, because the bracket is the common term across these 2 terms, here and here. And what would be left with after the cancelling is literally, and this is quite good to notice. So let me get this clear. what you're left with is the coefficients, should we call them, of the two brackets. They go in the last bracket, and that's actually going to be the case, as you can probably see evidently, every single time. So this question A. As promised, we get 2 examples. So let's do B. Again, 7 times 6. I don't really care if it's negative or not. I'm just going to get 42 there and think about factors. No, 4 doesn't. 5, 6, and 7. So we're done. And which one would therefore be best to get to negative 19? A bit more confusing, but, well, I'm going to pick this one. So 2 and 21 are how I'm going to proceed with this question. I'm going to be putting the 2 and the 21 in place of the B term. So I'm going to write the other terms, give it a lot of space, and think about which one is best to go where. This is where we need to think about common factors. Now 7 is awkward. It's a prime, and so we want to go with something that's in the 7 times table next to it. Before we put it back in, I'm pretty sure the 21's going with that. I need to know what sign it has. So how do we get to negative 19? We're going to do plus 2, take away 21. So that is in fact going to be negative 21x there. And then with the 6, we're going to put the plus 2x. This is a case where we don't have the same sign on both of these. So we're going to have to be careful about which one we pick. So now we've got the 2 sides. We're going to factorize out the term that is common in the left-hand side first, and then put it together with the right. That's a 7 and an x. And that's going to leave us with x in the first instance, and then 21 divided by 7 is 3. We're going to find out if that was the right choice in a second, because the brackets will be the same. If it's not, it will be this point that we need to go back to, and instead of taking out a 7, we'll take out a negative 7. But let's see. Over on the right hand side, we've got a 2 which is in common. That's about it. So let's just say it's positive 2 that we're going to divide out of there. If I do 2x divided by 2, I just get an x. Okay, that's good. We have an x in the other bracket as well. And negative 6 divided by positive 2 is negative 3. Okay, so that's a good sign. The 2 brackets that we've ended up adding here are the same. So now we just need to factorize that bracket out. And remember what I said about the numbers and the things that are in front, the coefficients of these brackets. This is what ends up becoming the second bracket. So even easier ways of looking at it. So you can double check that by expanding the brackets, but that's quite, if you look at the question, it's quite difficult, and the grouping method has made that relatively easy.